displacement value. And this type of question is needed in case we have like a powder to reconstitute in a vial or a suspension. So the powder will consume a space or a volume in the total solution, and we need to account for this volume in the final volume to calculate the concentration exactly. Let's explain it. So as you can see on the bottles for antibiotic suspension like amoxicillin, it's clearly mentioned here that you need to add 72 ml and the total volume is 100 ml. So the total volume is 100 ml. So we need to add 72 ml. This means that the powder of amoxicillin active ingredient will consume 28 ml from the total volume. So we have another example here. If the powder consume 15 gram, and so we need to add 85 ml to get a final volume of 100 ml. In case we didn't consider the volume displaced by the powder, so if we add 100 ml, so the final volume will be 115. So there is two different strengths. So in this one, we consider the volume displaced by the powder to get the accurate concentration. And in this case, we will get a diluted suspension because we will have the same 15 gram but dissolve it in a larger volume, which is 115. Okay, let's do the displacement value using a working example like this case. 250 mg of drug A has displacement value of 0.5 ml. That means 250 mg of this drug will displace 0.5 ml from the total volume of the solution. So what is the volume water of injection to be added to 100 mg vial of drug A to produce a concentration of 50 mg per ml? So in this case we will need 100 mg, not the 250, and the final concentration is 50 mg per 1 ml, and the answer needed to be in one decimal place. The first is to calculate the total volume of the solution. We need 100 mg vial and the 50 mg contain 1 ml, so 50 mg in 1 ml. So if we have 100 mg in X and the X is the volume equal to 100 mg divided by 50 mg, so the total volume of the solution will be 2 ml. Then we need to calculate the volume displaced by the 100 mg. So we already know that the 250 displaced 0.5, so we need to know what is the volume displaced by 100 mg. So 250 mg displays 0.5, so 100 mg displays X. So the X will equal to 0.5 multiplied by 100 divided by the 250. So 0.2 ml will be the displacement value or displacement volume per 100 mg. So we need to identify the volume to be added. So there is 0.2 ml displaced by the drug and the total volume is 2 ml. So we need to subtract these two values. We will get 1.8 ml, which is the volume need to be added to get the concentration of 50 mg per ml. Another way for the displacement values, a nurse must prepare a 50 mg per ml solution of ceftriaxone. She will dissolve 1 gram vial in 10 ml of the sodium chloride, 0.9%. Displacement value for 1 gram is 0.8 ml. So by adding 10 ml to the 1 gram vial, what is the final concentration of the solution? Give your answer to two decimal places. So in this case, we will use the displacement value, which is 0.8, to consider in the total volume, and this time it will be added to the 10 ml, and we will get the concentration by dividing with the total volume, which is the 10.8. So 10 ml added to 1 gram, so the displacement value will be added to this volume, so the total volume will equal to 10 ml plus 0.8, which is 10.8 ml. So now the 1 gram will be dissolved in 10.8, not 10 ml, which was added. So it will equal to 0.09359 gram per ml, and we've been asked to give it in milligram per ml to decimal places. So we'll multiply by 1000 to get the answer in milligram, and it will be 92.59.